everyone. Today, we'll explore the fundamental concept of chemistry, how atoms bond together. Now, first of all, a couple notes for this video. Elements 104, elements 104 through 118, aka Rutherformium to Ganoseon, which is labeled an anoctium in this periodic table, will be ignored because they are synthetically produced with very short half-lives, and we basically have zero data about them. Okay, with that out of the way, unfortunately, we also have one more thing to cover. Elements lithium, beryllium, sodium, magnesium, potassium, calcium, rubidium, strontium, cesium, barium, francium, and radium will be ignored in this video because they bond differently than other atoms. Now, let's get on to this. Let's imagine the atom carbon and silicon and selenium and iodine and argon. Now, each of these atoms behave in different ways. Carbon usually tracks four atoms along with the others in its column here. All of these elements. Silicon behaves the same way. Well, it turns out it does, but if something is double bonded, it will not react like that. But we'll talk about double bonds later. For right now, all of them are single bonds. Now, it turns out selenium behaves different. It, along with the others in its column, like oxygen and silicon, only gets 2. It technically depends on atom to atom, like sulfur is sometimes seen bearing 4 outlets in the case of sulfuric acid, but generally it's 2. And those ones like to double bond, so all of these molecular forms are hypothetical and may or may not exist. Now on to iodine. Iodine is part of the highly respected halogen system. The halogens really want one extra electron to complete their orbital. Hydrogen is kind of a less aggressive version of these atoms. The main one is fluorine. Fluorine is a halogen, and the halogen power gives it a boost. It's corrosive, just like all the other ones in the halogens, but it's so powerful that's the most reactive, corrosive element in the whole periodic table. So please don't be near it. Halogens like iodine get 1 extra hydrogen in this case, and here we have hydroiodic acid. And then argon actually doesn't take any hydrogens. Its orbitals are full. It doesn't want any atoms to bond with, and the noble gases just float around. Okay, now we're getting into more details. Oxygen has 2 electrons it wants to shed, and another oxygen also wants 2 electrons, so it shares all of the electrons to make each other happy, which means the double bonds they form respectively is actually sharing 4 electrons. Whoops. Same with hydrogen. Hydrogen technically isn't a halogen, but it behaves just like the halogens in only single bond because it only has 1 wanted electron. Oops, I'll fix the fluorine. It only wants like hydrogen and fluorine and all the other halogens. Well, again, hydrogen isn't a halogen, but we'll treat it as one. They just want one extra electron, nothing else to deal with. And then there are some others, and they are even more aggressive about this. Nitrogen, whoops, actually carries 6 electrons. They share 6 electrons because they usually triple bond. This means they each want 3 extra electrons. Instead, they join them together, resulting in 6 electrons, which is pretty cool if you imagine it. Oh, and besides, I want to mention that some items listed are so radioactive they really can't be counted. Radon is the only exception to this. It is super radioactive, but it's still really just a noble gas. Astatine is not counted in this video because it is way too radioactive and it'll just blow itself apart the moment it is created. Now, all the elements over here behave a bit differently. It is really hard to tell the bonding of these. For example, iron will just take whatever is there. Usually, it ends up doing this. Rust. Others behave slightly differently. Say you have an atom of copper, and it'll take one. But honestly, it's really anyone's guess which bond it'll take. If you want, leave in the comments if you think copper oxide CuO has a single bond, a double, or a triple. Now we have hypothetical molecules. Again, thought to be electropositive. You may want to consider these. It bonds with tennessine in single bonds, though again, they are just radioactive. We really don't know anything about them, and they'll just blow themselves up the moment we'll create. So by aganocene tetratennessine. Okay, so that's it today. Stay safe, have fun, enjoy, and always stay away from the dreaded bromine molecule. See you later. Bye.